To continue on with our rig, we created the joint structure, and which I will come back to in a little bit, but I want to start explaining constraints as well as the IK, the different IK handles that we can attach to the joint structure and how those actually work. So in the rigging menu set, I'm going to just create a simple joint structure, and switching here to the side view. And then I'll go ahead and create that. Very simple, I don't need much. I'll also pull up my joint size menu, and I can reset that. All right, so here we have this. Got moved a little bit off base, that's okay. So, so here we go. We have this structure here, and let's demonstrate IK handles. So under the skeleton menu, let me just tear this off. I have this create IK handle, and then we'll talk about that as well as the spline handle and then the differences between the two. So what we want to do, a couple of things to note. There's FK and IK. There is forward kinematics as well as inverse kinematics. So forward kinematics deals with the actual rotation of the joints. So for example, if I were to select the rotate tool and rotate this, let's pretend this is a knee, and rotate this knee, this right here is using forward kinematics. Let me take a step back. Now, the problem with that is sometimes it just, it is a lot of work. So for me to be able to, for example, let's say I need to move this leg up, but then I need to bend this knee down. This is how much work is required to do something like that. So you go through several movements to get that done. Now, with an IK, inverse kinematics, we essentially focus on the position of these IK handles, and then in turn they start moving the joints for you. So let's explore that. And here in the create IK handle, let me go into the menu for the tool settings for that, and then explain a couple of settings in here. So we have the current solver, which is currently set to rotate plane. Now, there's also a single chain solver, and then I'll demonstrate both. So if I do a single chain solver, and then with that, I can actually close out of this. To create my IK handle, I'm going to click on my top joint here, and then I'm going to click on the one down here. Now this creates the IK handle. With the IK handle now, what you do is you move, so here it is, so you move the IK handle. In this case, we're not doing the rotate, and in turn it moves the joints in the structure that we have. So very convenient. Now, the thing is, if I were to take, let's say, this IK handle, you know, and here I'm trying to rotate this, the problem is it's not really beneficial. Let's say this was a knee rotate, because the IK handle is focusing on motion, on positioning, but now we're including the rotation in there as well. So in this case, it's actually best to go with the different solver, the other solver that we have. So I'm going to select this IK handle, delete it, and then I'll just kind of start over. Create IK handle options. Instead of single chain solver, I'm going to do a rotate plane solver. This is going to be pretty helpful. We'll come back to these settings in just a bit, and I'll explain to you what those are. But for the time being, I'll close out of this, click on here, click here. Now, what you'll see here at the top is this rotate plane. So now I have this nice kind of, again, the IK handle that moves the joints in the structure, but now I have the rotate plane. So a couple of things you can do here is you can do, let's see, we have our transformation tools. The one that's going to be the easiest to use with our rotate plane is actually let me grab I'll probably do the manipulator tool. So now with the manipulator tool being here, now I can move the rotate plane, right? And then so here's what happens. So let's say I move the rotate plane, which actually, watch what happens in the channel box. It's this pole vector that's created, right? So I can move, let's say this is a knee, move the knee here, while also I can grab this IK handle and move it up. So again, we kind of have this individual, you know, kind of like this different way of grabbing our joints and then in turn moving our structure. So this pole vector adds that rotation that we're looking for if this was a knee. So definitely the rotate plane would be the way to go. Now, just something to keep in mind, let's take a look at some of the settings we do have. All right, let me just kind of move that, right? Right now we're kind of rotated, so I can put that back. And then let's just explore what's going on in the attribute editor real quick. We have the skeleton info, we have our regular transform controls, but right here we have the IK handle attributes. So we have something called stickiness. So what happens right now, if I were to select, I really don't have a lot of joints here, I have my 3 joints. Here we go. So let's say I'm over here kind of moving the joints around. So what I could do is kind of turn on the stickiness. And then keep. And then you'll kind of have to play with this to see what actually happens. It maybe is kind of hard to see. But what happens is the joint continues to actually be constrained to the IK handle. The stickiness keeps it in place. Watch what happens when I try to move this joint up here as opposed to what happens when I turn stickiness off and then I try to move the joint, right? It kind of it keeps this joint from moving. This one moves up, so it doesn't have, it's not sticking. It's not sticking to the IK handle. So this is kind of a big one to keep an eye on, is the stickiness right here. Now, here's the, let's see here, if I go back to my IK handle, let's see if there's another thing I can check out here. Down here, the IK solver attributes, and this is where you can see that you actually do have the ability to switch from single chain to rotate plane and vice versa after you create the IK handle. Also, we have this IK blend. So the IK blend essentially takes you from forward kinematics to inverse kinematics. So if I were, right now, here's me moving the IK chain. Now if I set this to 0, and then I move my IK handle, it no longer works. It's not attached essentially to my joint. So the joint can move kind of independently here, right, without being affected by the IK handle. So that's what the forward kinematics, which we'll kind of see a little bit more in action here in just a little bit, and how we can blend between the two. All right, so, well, and now that we're actually on here, maybe this is a good time to show you how the IK blend works. And in this case, and we're gonna do this, I'll probably just use the channel box. So let's see how this works in animation. So the idea of FK and IK blends is that you do have the ability to do both. Let's say you do want to specifically bend certain joints and rotate them. Let's say you want to rotate them, but you also want to have the ability of constraining yourself to an IK handle. So this is where this IK blend will come in. Now, let's say I start keyframing this, right? So right now I'm an IK blend 1. I'll just press S. This will keyframe everything. Let's say I come over here to about 10 frames, and then I haven't moved this. Let me see if I maybe I'll just preserve it. Maybe I'll just keep it as is. So press S again. And then now let's say I come over here, bring this up. So maybe at about 15 here. So press S again. All right, so very simple motion, not a whole lot going on here. Let's say at about frame 10 now, I'm going to select my joint structure and actually keyframe that. Keyframe the position of that. Maybe at about frame 15 or so, this is where I'll want to maybe rotate this. Oh, actually, sorry about that. This is where I'm going to turn off my IK blend. I'm going to do 0. Just make sure, again, this is all keyframed. And then take my joints here, and then I can, let's say I want to rotate them up a little bit. Press S. So here we go. So right now, this is a combination of IK and FK. We started with IK. So let's take a look at this. And right about frame 15, I disabled IK. So basically now we've switched to the forward kinematics, and now I'm able to actually keyframe and rotate the joints. So let's say about frame 20, I'm going to put this back at 1. Just press S to make sure everything is there again. Okay, so and then here's what happens, because now we have the blend between the two. You'll kind of get this little bit of this ghosting information. This just indicates that there's also an FK and IK blend going on. So that is the benefit of having both. So in case you do want to rotate your joints without being constricted by the IK handle that's placed, this is that the attribute that you will be focusing on. All right, so moving on, and I'll just create a new scene. Now we're going to come back to the IK chain, but I just want to show you, and we're not going to continue working with the IK spline for just, for now, but we will come back to it. But I want to at least show you that it is set up differently and it functions a little differently. So I'm going to create a joint structure that's going to be maybe from the side view. I'm just going to make it kind of windy. There we go, a little curved. So now that we have that, I'm going to do an IK spleen handle. Now, here's the thing, and let me just demonstrate this. If I have an IK handle and I place it here, and let's say here. Now, when I come over here to my move, I mean, it's okay, right? It does bend essentially, but it's not what I want. It's not exactly accurate, and it's not doing exactly what I'm kind of hoping it would do. So in this case, let me delete that. I'm going to use the spline IK, and then let me just take a look at some of the settings that we have here. We have root on curve, auto parent curve, auto create curve, which is exactly what we want. So what's happening with the spline is, in place of this little line that we get from in the IK handle, there's going to be an actual curve that will be created to run through this joint structure. So the number of spans I do want, because let's say in this structure I do have quite a few joints here, so I want to have a little more of an accurate control. So I'm going to change the number of spans. In this case, let me try about a 3. And now with the IK spline handle, I'm going to click here and then click on the last joint. So here it is. Now here's the thing though. This doesn't function the same way. I can't just grab the move tool and move it. And this is where we'll have to kind of come back to this. I'll come back to the spline IK when we get into the actual character model. But as you can see, it functions a little differently. And then what I can show you for now is that this actually has a curve. So, and just like with any NURBS curves, it has these control vertices. If I select my control vertices and move the structure, watch how it moves Watch how the structure moves along that curve. It really kind of has a more natural motion if we're dealing with, maybe it's a spine or a tail of a character and so on. So essentially, these points are now controlling the motion of our joints. Now we'll have to set up a rig for this. Again, it doesn't just take a move tool and move the IK spline handle, that handle, but so what we'll have to do is attach essentially some clusters we can use to attach to these points to better control the curve. So here it is. All right, now again, this is something we'll have to revisit, but I want to go over some of the constraints and how they work. So going back to my simple joint structure, let me go to the side view here, and then I'm just going to create just something simple here again. Nothing, I don't need anything fancy. So we have something like this. What I'm going to do is set up a simple IK between within this little joint structure. So create IK handle tool, click here, and here's my IK handle 1. Now, okay, it's moving, it's working. Now here's the thing though. Remember that these joints are placed inside of your character. So essentially, the whole point of a rig is that it makes it easier to control these joints, which in turn affect the way the character behaves. And it's easier to do that when controllers are placed somewhere on the outside of the character visually, and that they function properly and they affect the joints properly. So in a lot of cases, constraints are created, and I'll tear this menu off. Constraints are created to in a rig, and we'll see all of that when we get to the actual controller section and creating the rig for that character that I created. But for now, let me just go through some of these constraints. Now, there is a parent constraint. This will deal with parent-child relationships in the joint structure. We have the point constraint. So that is essentially an object pointing to another. Orient deals with rotation. Scale is obviously scale. Aim is aiming something at an object. So this would be a good one for eyes. And then we have the pole vector, which essentially handles that additional rotation of the joints that you have. So let's explore the point constraint and how that works. So let's say I have the structure and I want to create a controller. So this is actually already getting into a little bit of how controllers work. So a controller is something that you're going to create to give yourself a visual cue of basically which joint you want to move. So I'm going to use a simple curve circle. So it's a NURB circle. And once you place it, it automatically gets placed in the center here. I'll just make it a little bigger. So that's fine. Another thing you can do is you can snap it to the joint in case it isn't. So I'm going to go ahead and snap that. Here we go. And then turn off my snap control. All right, so my whole goal is that I want to use this circle to control the IK handle. So to do that, I'm going to select the circle and then select the IK handle and then go into constraint point options. Let's just check this out real quick. I don't have an offset. Maintain offset. Let me just explain this one and we'll end up using it at some point. Now, maintain offset is something that we want to select where let's say this circle was out here, right? But then the actual IK handle is here. We want to maintain that offset between the two. And that's what this is for. Right now, I really don't need to select it. Both of them are kind of placed in the same position, so I should be good there. And then from here on out, I don't need to constrain or be specific as to which constraint, so I'll just leave it as is, and then click Add. Now, this NURB circle, when moved, actually affects how it basically controls the IK handle. So anywhere I move it, I'm essentially moving the IK handle. Okay, let's say I put it back. Now here's the IK handle, and then in the outliner you'll see that it has a point constraint attached to it. Now if I select the IK handle and move it, here's the problem. The circle stays. So we can actually fix that. So if I select my controller, go into the attribute editor, let's just see what we have here. So I have my IK handle point constraint. And then here's an option that I can select. So I'm going to lock output. And then if I grab the IK handle now and try to move it, it doesn't move. So that is also an option that you have here within the constraint attribute editor. So that is a point constraint. Now let me just create another one. So what I'm going to do is I'm just going to take my circle, duplicate it. I'm going to move it up and then snap it into place. Here it is. Turn off my snap. And then I'll do the same thing. I'll do another point constraint. So I'm going to select my NURB circle. In this case, I'm going to select the top joint and then do a point constraint. So now this, watch what happens. Now I'm able to grab that circle at the top, and now moves my my top joint in the structure. Here we go. I'm going to select my quick structure here. Okay. And then set up my IKs. Okay. And then I'll go back to that circle. And let's say here we go. I can just put it here, for example, for now, just to show you how this works. So I'm going to be using this for orientation. So with that selected, I'm going to select the top joint, go to orient, and then just click add. See what happens when, so let me explain this. So here's what's going on right now. Let me undo. Look at this top joint. Watch how the arrow, right, this X, is pointing this way. So is this, right? So what's going to happen when I create this constraint without maintaining the offset, it's going to follow that rotation. So that's kind of the problem here. If I click on maintain offset and click add, now I'm okay. Now another way to go around that is, let's say we do orient constraint, check that off, and then click add. See, here it is. So what we should be trying to do is actually trying to change the basically the rotation, the orientation of the circle in relationship with the joints. So that's kind of another thing to keep in mind. So this is where, again, in this case, if I do maintain offset and click add, now I'm okay. And now when I select this, and let's say I rotate it, right? So now this orient constraint is changing basically the rotation. It's affecting rotation of this joint structure. All right. So let's say I have, and I'll just kind of do it off on the side here, and actually, you know, just demonstrate this because I'll just use another, this for a different exercise. So I'm going to select this joint orient constraint and then just delete it. So the nice thing is you don't have to, you know, that's the easiest way to get rid of it. So what I'm going to do is I'm just going to set up a couple of spheres here, and we're just going to pretend these are eyes. So let's say, here we go, And then I'm going to, let's see here. Probably would have been easier. Let me just do a quick poly. I don't need it to be so complicated. So I'm going to select this. Assign new material. Here we go. So this will be a Lambert. And I'm just going to make this dark. And I can smooth this out. So let's say we have an eye. And then I'm going to duplicate this and then have an eye out here as well. And then let's check out this aim constraint. So if I have two eyes, two sets of eyes here, set of eyes, I'm going to create a locator. And then I'm going to use this as the object that the eyes are pointing to. So here it is. It's between the two eyes for now. All right, this one's pretty straightforward as well. So I can take one of the eyes, or I'm sorry, I can take the locator first, select the eye, and if I go into aim, again, you have your maintain offset, which if I were to click off of that right now and click add, all right, here we go. So now if I'm moving this, the eye follows. So let me undo that just to kind of demonstrate this one more time. Okay, and then aim constraint. That was maintain offset. If I click off of that, watch what happens. Click add. So now the sphere is pointing up. So what you could do, however, in this case, is if we go under the aim constraint, you have this aim vector. So if I hit 0 here, and I believe it's kind of hard to, let me see here. Let's see. There we go. So we're going to change the aim vector y-axis to 1 as opposed to x. So now this actually does point directly at the aim vector. So that's kind of a good way to fix that issue. I'm going to select this eye and then do the same thing. So actually in this case, let's select the locator, select the second sphere, and then I'm going to do another aim constraint. And again, I'm going to just leave off maintain offset just so I can show you again how to fix that. Click on that. And then go into this constraint, go into the aim vector and change it to the y-axis. So now you have kind of, here we go, right? The eyes are pointing at the object. So they can go this way. If I go further out, then they kind of straighten out. But essentially, here you go. That's the aim constraint. So this is going to be perfect for us when we get to rigging the eyes. All right, so with that said, I'll just kind of leave that there for the time being. Let me check out my, my joint structure here. And then I'm going to set up some, well actually this is a little distracting, so I'll just delete that. And then I'm going to focus on this chain here and then set up a couple of quick point constraints. All right, so kind of going back to what we did in the beginning of this, I'm going to select the NURB circle with the IK handle, and then I'm going to do a point constraint. And actually, very quickly, let me see if this is snapping to, there we go. And then I'm going to do a point constraint here. Let me see what happens when I don't maintain offset. Okay, that's fine. So there's that. And then I'm going to create another NURB circle, which in this case I could just duplicate it, so Command D. If you duplicate, it doesn't duplicate the constraint, but just the circle that we can reuse, which is perfect for us. And then I'm going to do a point constraint here. So now I kind of have my motion here, which actually that is working very weird. Let me fix that. Let's see what happens if I do this. Oh, I don't like that rotation, so maybe, let me just check on this here real quick. That still twists, but for the time being, I'll just leave it alone. Kind of want to see what happens when I do the next part. All right, so I'm going to create another locator. All right, and then I'm going to select my IK handle. And I'm going to do the pole vector here. So now with this pole vector, the pole vector is now dealing with actually rotation. And then let me bring up the channel box. Okay, so here it is. This IK handle now has a point constraint, but it also has a pole vector constraint. So this is dealing with that right here, that pole vector, which was the part of the, let me just go back to that, when we were creating the IK handle. So this is where this becomes, this rotate plane solver becomes very beneficial, because your pole vector constraint will essentially affect that rotation that we need. So now, not only will you have the controllers for this leg motion, but now you have the pole vector to also affect the rotation. So that's the benefit of doing this, a pole vector constraint, but also the rotate plane solver. All right, so those are just some of the basics of setting up IK controllers, and then or IK handles, and then some of these essentially controllers. We're getting into setting up controllers and then learning the different constraints that we're going to be using. Now, we're also going to use some parenting as well, so we'll be revisiting that, but we should be good to go and start on our character next.